Here's an example of how we would use this remainder estimate. Okay. So a typical kind of question is, how many terms do we need? So if we want to estimate the sum of the piece series from k equals 1 to infinity of 1 over k to the fifth, we see here the power p is equal to 5, which is greater than 1, so the series converges. But to what is the question? And if we're going, so the way that we estimate this is just adding up partial sums. But we want to know how many terms we have to add up before we can be sure that the error between our partial sum and the actual sum is less than 2.5 times 10 to the negative fifth. All right, so the approach we're going to take is we're going to use this remainder estimate, so n plus 1 to the infinity of 1 over x to the fifth is going to be less than or equal to the remainder, which is the sum of the of all terms with index greater than n. And this is less than the integral from n to infinity of 1 over x to the fifth dx. Okay. This is a p-series, so it's decreasing, it's continuous. And what's the other condition we need to check? It's positive. Good. Okay, so we're going to find the n so that, well, we want to make sure that our n is less than 2.5 times 10 to the negative fifth, but that's hard to calculate. Instead, we're going to find the n so that this upper bound is less than 2.5 times 10 to the negative fifth. Okay, that way, if my upper bound is less than 2.5 times 10 to the negative fifth, then for sure my remainder term will be. Okay? And in our case, this upper bound is a lot easier to calculate. Okay, so let's integrate. So the integral of 1 over x to the fifth is the integral of x to the negative 5 dx, which is x to the negative 4 over negative 4. Right? So the integral from n to infinity of 1 over x to the fifth dx is equal to the limit as b goes to infinity of b to the negative 4 over negative 4 minus n to the negative 4 over negative 4. Okay. So this is equal to 1 over 4 n to the fourth. Okay, and we want to know for what n is this less than 2.5 times 10 to the negative fifth. Okay. All right, so that means that we want 2.5 times 10 to the negative fifth to be less than or equal to 4 times n to the fourth. And we should have 2.5, oops, excuse me, this is not 10 to the negative fifth, so we took the reciprocal of both sides and we had to flip the inequality. So this is 2.5 times 10 to the fifth. Okay, so we want 2.5 times 10 to the fifth divided by 4 should be smaller than n to the fourth. Okay. Now we can take the fourth root of both sides. So n should be greater than 10.5 times 10 to the 5th over 4 to the 1/4 power. All right, so I used my calculator to work out what this cube root is equal to. It's about 15.8. So that means that if we add up at least 16 terms, then the difference between the sums starting between the entire series and the first 16 terms added together is going to be less than 2.5 times 10 to the negative 5th. Indeed, we find that our sum of the series is less than or equal to 2.5 times 10 to the negative 5th plus whatever this sum ends up being. Okay. And we know that our sum is going to be more than just the partial